Welcome back to learning how to program with JavaScript with me, Paul Baumgarten. Today's lesson builds upon what we've been using previously. We will use variables, we will create our own functions, we'll have if selection statements happening, and we'll take the concept that we learned last lesson of mouse event handlers, and this time use event handlers for the keyboard and also a timer interval event. So by the end of this lesson we will have a little game up and running. So let's get started, shall we? We'll start off by drawing an exciting little circle. Right, and so we might have a circle, let's put in 50-50 for now, and give a radius of 20, and this will be our character, so let's make it blue. Okay, and if we load that, okay, we've got a little blue dot. But we know that if we want to do anything with this, we need to use variables instead of hard coding things like our position. So let's create an x coordinate, and let's create a y coordinate, and we'll use those instead of the numbers. Okay, and we still have our circle in the right spot. Okay. Now, let's make our circle move in response to what we do on the keyboard. So just like last lesson with the mouse, we use document add event listener. But this time, instead of mouse move, we're concerned with whether a key is being pressed down. Okay, and when that happens, let's say we want to run a function called keyboard. So we will write a function called keyboard, and just like with the mouse, we will receive a parameter that contains information about the event that occurred. And let's just say if. Now we want to control this circle using the arrow keys. Now the problem with the arrow keys is that they don't actually type a character onto our screen. Like if we wanted to control it using A, B, C, D, we could do if e.key compares to A, do something, okay? But the arrow key doesn't actually type a letter as such, so we actually have to use codes for these things. And every key on the keyboard has a certain code that can be used for checking. So for things that don't have a printing value, we just use these codes. So if we want to know what codes to use, a handy little website that we can use to look these up is keycode.info. And I'm not actually connected to the internet at the moment as I record this, so it won't come up. But if you run it on your computer, you should see, you should be able to, it'll basically let you press any key and it'll tell you what the codes are. And if you were to do that for the arrow keys, all right, so instead of checking against the key, we're going to check against these key codes. And so 37, I'm going to put here a little comment, 37 is the left arrow. All right, else, okay, and so then what do we want to happen when we hit the left arrow? We want to take our x value and say reduce it by 20. All right, so remember, we evaluate what is on the right, so whatever number is an x, in this case 50, minus 20 from it, store the answer in what's on the left. So store the answer back in, so by the time we've finished executing this, x will be 30 the first time it runs. All right. Else, if the event key code is 39, all right, then we want to do something else. And 39 just happens to be the code for the right arrow. Else if e dot key code equals 38, right? 38 happens to be the up arrow. Else if e.key code equals 40, you can guess what this one is, the down arrow. All right, now pause the program at this time and see if you can put in these adjustments yourself. And then you're back. All right, did you manage to get that this would be x equals x plus 20? This will be y is equal to y minus 20 because we're heading up. And y is equal to y plus 20. All right, and we want to draw the circle whenever we change these values, because otherwise we've got one circle that's here. I think my Chrome is behaving strange since I'm not actually connected to the internet. That might be why it's not constantly updating automatically. So maybe I should quickly do something about that. Sorry, just talk amongst yourselves for a second, or quickly skip over this bit until you see me moving again. Tailoring. Okay, I'm back. Apologies about that. I might try and edit that bit out. Okay, now we have our circle appearing all the time. All right, so we're back. We've got these if statements that are changing my x and y values. Now I need to draw the circle on the basis of the change. So let's copy this line and paste it into here. And that'll draw us a new circle at the end of processing this event. So now if I hit play, alright, I'm hitting my arrow keys and I'm getting a pile of circles drawing. Now, I might not want that trail, so I just want a dot that travels. Okay, so every time we draw our circle, let's paint over it with a big white rectangle. So we reset our screen. So we're just going to draw. Let's turn off some notifications. Okay, draw rectangle from 0 to 0 to window.inner width, window.inner height, and we want our rectangle to be white. Okay, so inner width, inner height, basically these are variables that tell us this is the width of my screen and this is the height of my screen. So now as I run this, alright, I've got a blue dot that travels with me and it keeps getting, the screen gets cleared with that white rectangle. Okay, if I had made this pink, then I would be having a pink rectangle as I move my screen. Okay, there we go. So we've got keyboard event happening, okay, and we're using the event data, we're using the key code that is attached to it, and we're comparing it against the codes for the arrow keys. We could use other keys as well, okay, so we can, what if we wanted to use, say, the space bar to jump to a different location, so we'll use it to quickly get out of the way because we're about to be attacked by the enemy that we'll create. I can come back to my keyboard if statement here and just add another else if e dot. Now I don't need key code because the space bar does type a key in program, so I can just open a quote and put in the space because that's the symbol that I'm looking for. Okay, open up some braces. But I might just, for the sake of completeness, put my comment here, space. So I want to jump to a random spot somewhere in this screen from 0, 0 to the width. So let's use random. Okay, there is a math.random function in JavaScript. Now this returns a number between 0 and 1. Okay, so like it might be 0.1, 0.00349, okay, whatever, some kind of decimal between 0 and 1. So then we multiply it by where we want to end up. Okay, and I want to end up from, say, between 0 to 500, so I'm going to multiply by 500. But it still might be a decimal, so I'm also going to use math.round. Okay, so whatever random number I get, times it by 500, and then that answer goes into the math round. So round is going to round that number for me, and I'm going to set that to x. And I'm going to do the same thing for y. All right, now if I run this, and I'm using my arrow keys, hit the spacebar, 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 spacebar. Okay, so I'm moving a random location based upon this little randomness here. Okay, this is all well and good. Now let's get a bad guy chasing us. Okay, now to do this, for most computer-controlled movement or animations or that kind of thing, you're going to use the timer. And the timer basically works the same way as the event handlers do. But what we're doing is we're triggering an event based upon a clock. And the way that we do this in the code is we use a set interval command. So set interval, I'm going to put in here, follow 40. So let me explain what this is doing. Set an automatically executing clock, okay, with an interval, okay, based upon an interval, to run this function, follow, every 40 milliseconds. Now remember, there are 1,000 milliseconds in a second, so 40 milliseconds means it's going to run 25 times per second. All right, and I picked that number because TV video, at least in PAL, countries that use PAL, TV video, which is Europe, Asia, etc., those TVs run at 25 frames a second, and that looks pretty reasonable to the human eye. NTSC is the other type of TV video around, which is mainly North America. They run at 29.9 something frames per second. I'm not worrying about that. 25 sounds good to me. But, so every 40 milliseconds, look for and run the function called follow. So, I better create this function follow. Okay, so we're going to make another dot that's going to follow and chase after our blue dot. So again, we probably want some coordinates that we can use for this. So I'm going to create up here, go back up to the top, and I'm going to have a chase x, right, and I might start it at, say, 500, and I'll have a chase y. Yeah, let's start this at 400. Okay, so x of 500, y of 400, so it's going to start around here somewhere. Okay, so inside my follow, now how can I have one dot chase after the other one? Well, this chasing dot has access to the privileged information of where my keyboard dot is. It just needs to look at the x and y values. Okay, and if we think about that, to chase up, to get closer to the blue dot, basically if the blue dot's x value is less than my chase's x value, I need to decrease this x value. If the blue dot's x value is higher, then I need to increase my x value until I'm matching it. And then the same happening with my y. So this would kind of look like this. Chase x. If chase x is less than x, right, make chase x bigger. All right, so we'll make chase x equal to chase x plus 1. Okay. Else, if chase x is already bigger than where the blue dot is, then we need to reduce what's inside chase x. Okay, and we do the same with our y. So if chase y is less than y, chase y needs to become bigger. Else if chase y is already bigger than the y value of the blue dot, chase y is to reduce. Okay, sounds good to me. Let's see what happens if I come over here, start moving around. All right, these values would be changing, but I don't actually have it drawing a dot for me anywhere, do I? So let's do that. Draw dot circle, chase x, chase y, yellow. Oop. Let's make it yellow with a red outline. Okay, and now what's happening here? Eh? It's not showing up, and the reason it wouldn't be showing up is what have I missed? Follow. Yes. Oh. All right. So I don't have the radius of my circle. There we go. It's chasing after me. If my blue dot moves down, it'll start coming in that direction. Okay, let's get this rectangle drawing again. All right, now you notice how it has a trail until I start moving again. Okay, and that's because the rectangle only gets drawn when I move. But likewise, if I put the drawing the rectangle down here, then when I don't move, my circle is going to disappear. So the way to fix this is to put all my drawing into a separate function. All right, draw everything. And so I'm going to grab my rectangle that clears the screen, cut it from that function, paste it into this one. I'm going to take the circle that represents my person, cut that, paste it into draw everything, and I'll take the circle that represents the bad guy, cut that, and paste it into draw everything. Now all I need to do is anytime I want my screen drawn, is I need to remember to draw everything. Okay, so I can do that just by coming into here, draw everything. Okay, and this actually happens 25 times a second, so I probably actually don't even need to add it into the keyboard event, which is what I was thinking I might do, because it still updates often enough that you can see the keyboard responses happening quick enough. All right, so I'm being chased, and if I wait, when he approaches, if I hit the spacebar, I will jump to another spot, and it will automatically start moving in that direction. All right, now obviously I can speed this up by changing these numbers. Instead of chasing by the rate of chase of only being 1 pixel at a time, we could make it 5. Okay, and now it's going to chase a lot faster. Oops, yeah. Okay, now you see that little jiggle that it did there a second ago? Right there. Okay, that's because we're not landing exactly on the blue dot. Right, we're either the blue dot is on an increment that's not evenly divisible by 5, so it keeps adding 5, reducing 5, adding 5, reducing 5, trying to get on the dot, and it can't. So there's a couple of ways we could do that. We could increase our if statement here to be checking, if the difference is less than 5, then we just change by 1. If it's bigger than 5, then we change by 5 or something like that. Okay, or the other way is we could modify our round up here so that we know that it's increments of 5. So we could divide it by 5, whatever happens here, and then times it by 5. Now, why would that work? Let's just show that it does, first of all. Why would dividing something by 5? Okay, you can see we're not getting the little jiggy movement happening anymore. Why would dividing by 5 and then timesing it by 5 work? Shouldn't we end up... sorry, the spacebar is going to be... Oh no, this was the spacebar one. Because what I'm missing was math floor of the division. Okay, so math floor is basically saying chop off any decimals. So we'll divide by 5, times it by 5, and so any portion, any fractional portion of that division by 5 will get eliminated. And so we'll always get a nice clean number. And so now if I hit the space bar, we're not going to have the violent shakes. Because it's always going to be divisible by 5 wherever we land. Okay, so we're chasing after me. Fantastic. Well, our game is almost finished. But really, we should know, we should let the yellow dot have a sense of victory. You know, some kind of celebration if the game is over because it has defeated us. So let's add that in, and that would probably make sense to happen here in the follow, because this is where our yellow dot is getting its coordinates. All right, and the yellow dot has captured us if its coordinates are the same as our character's coordinates. So if chase x is the same as x, all right, and if chase y is the same as y, all right, then let's have a game over function. So let's come up here, function, game over, and this can be nice and simple. Let's grab our clean rectangle, except maybe instead of pink, because we're upset we lost. You know, maybe let's make a dull grey color. And we'll just draw some text on the screen that says game over, and put it kind of roughly in the middle of the screen. Alright, but then we come back down here. Anytime game over happens, we're then drawing over it with our scene again straight away. We only want to do this when the game is still playing. So if chasey equals this, then the game is over. Otherwise, or else, draw everything. Okay. Now this only executes if the x coordinates match. Okay. If they don't match, we still need to draw everything. So let's come down here. Else. Now, those who know how to program will be looking at this thinking this if statement is quite disgusting. Because we can actually combine all this into one statement by using an AND command statement expression. And so the way this would work is if chase x equals x, 2 ampersands mean the word AND. Right? So if chase x equals x and chase y equals y, then do something. Now the only catch with this is the selection statement of an if statement. Excuse me. The condition we're checking for an if must be enclosed in one set of brackets. And here we have two. We've got this and this. So to enclose it in one set of brackets, we would put another bracket at the start and another bracket at the end. So now there's one set of brackets that has the condition, which is then being split into two parts. Now you don't need these spaces, I just put them here to make the bracket stand out. So we're now checking for the x and the y value at the same time with one if statement. So if both of these are true, then it's game over. Else, not game over, so we'll draw everything. And now I can just get rid of that if statement. All right, and alright, so if I move around the screen, try and avoid getting captured by the dot. When I get caught, game is over. Fantastic. So we've got a very simple little game, chase the dot, but we've learnt how to use the keyboard event handler, and we've learnt how to use the timer interval function, both of which just automatically trigger these functions for us. Okay, I hope you found that of value, and I will see you next time.